Hi, my name is Rachani Veerapandian, CE200140 from Group 40. Today I'll be presenting about calculation of our project circuit. So this is our circuit. So we have 10 volt DC and we have two resistors. One is 25 ohm, another is 100 ohm, and we have inductor 10 millihenry and capacitor 800 nanofarad. So this is our graph. So VST over T. So this is our FT. So when FT is 10, the T range is T is more and equal to 0 and less and equal to 1. So next FT value is -10. T is more and equal to 1 and T is less and equal to 2. So the period for this graph is 2 and the omega naught is pi. So this is the calculation for A naught. So this is the formula for A naught. So we insert the FT value and the range in here, and the answer we get is 1/2 for A naught. And this is AN. So this is the formula for AN, and this is the method. We insert the FT and the range, and we will get the answer 0. So for BN, this is the formula, and we insert the FT and the range, and then we will get the answer in odd and even condition. So for odd condition, n equals to 1, you will get 9.5. For n equals to 3, you will get 10.5. When n equals to 5, you will get 6.3. For n equals to 7, you will get 4.5. So next, for even condition, when n equals to 2, you will get 15.7. When n equals to 4, you will get 7.9. For n equals to 6, we get 5.2. For n equals to 8, we get 3.9. And this is the equation for FT. And that's all from me. Thank you.
Hello and Assalamualaikum. My name is Muhammad Haziq bin Muhammad Noor. So today I'm going to demonstrate to you about the simulation of a sample circuit, as you can see in front of the monitor. The sample circuit that we want to determine the FFT voltage at load. I choose R2 load, FFT current at R2 load, and FFT V input from our digital signal. So as you can see, this is our sample circuit, which is consists of 10 volt amplitude, positive amplitude, and negative 10 volt for negative amplitude. And it consists of 4 components, which is 2 resistor, 1 inductor, and 1 capacitor, with the value of 25, 800, 110 milliamps. So if you want to drag the component, just click over here and choose the component that you want, and just place the component and wire it one by one. So after you wire the component, after the component is wired completely to run simulation. So actually this is V1 is positive amplitude, V2 is negative 10 amplitude, TD stand for time delay, which is 0, TR rising time 0, falling time also 0, and pulse wave is equal to 1 millisecond, because inside the proposal circuit waveform we input 1 millisecond. So if you want to get the FFT for V input, place the probe at here. Place the probe. Actually, you need to click edit simulation profile. So when you click edit simulation profile, it will appear like this. Okay, it will appear, appear like this. So I put 10 milliseconds for maximum. And click apply, click OK. And then click the play button over here to get the V input and FFT of the Vsauce. So click play button, run simulation. It takes time a while. So when you click, after you click that, another monitor will appear. So click here and then click here. So this is the monitor that I say just now. So at 50 voltage, you see this is the graph uh, from the sample circuit that we put 10 volt and negative 10 with 1 second pulse wave. So if you want to get the FFT, click here FFT. So if you want to make more detail, click plot, exit setting, and go to user define. We make it about 5 kilohertz. So as you can see, at 0.5 kilohertz, our voltage is about 12 to 13 volt, while 1 kilohertz is about 0.5 something, and 1.5 kilohertz is about 2.5 volt. So that's 54 for V input. Now we continue to load. So if you want to continue to load, put V marker over here. So we want to determine the voltage for R2 and click play button and wait for a while until the extra monitor appear. It's a bit late because my PC is hanging. So click both. Okay, now you can see the FFT appear. So you want to make it you want to make the signal become FFT, click FOURIER and go to plot, exit settings, user define as usual. I already showed this now. 5 kilohertz. So the maximum is for 5 kilohertz. You can see at 0.5 our voltage is about 2.4 or 2.3 volt, while 1.0 kilohertz is about 0.8, while 1.5 kilohertz is about 1.9, and 2.0 kilohertz is about 1 volt. So that is the FFT for R2 load. Now for the final part, and you can see 2.0, 2.5, and 3 has the same value of voltage, which is also 1 volt. So now we go to the last part, current. So click delete, click current, and put over sorry, wrong. Over here. Up a bit. Okay. Now click run simulation to get the current at R2 load. Click share. Okay, so as usual, click FFT. Click FFT. This is to determine the current at R2 load. Click plot, exit settings, user define, and change to 5 kilohertz. So at 0.5 kilometers, our current is about 22 milliampere, and 1 kilohertz is about 8.8 something. At 1.5 kilohertz is about 20 milliampere, and 2.0, 2.5, 3.0 kilohertz is about 10 milliampere current at R2 load. So that's it from me. Thank you.